Have you ever used a piece of software or an app and just thought, wow, this is brilliant. It does exactly what I need it to do. And then, of course, you've used another one that was a total disaster. It's confusing, it's slow, it's just wrong. Well, the difference between that success and that failure, it often comes down to one single critical thing, something that happens long before a single line of code is ever written. It all comes down to the blueprint. So let's break down what that means and why it's really the secret to success.
It's a huge question, right? It's something that keeps project managers up at night and honestly frustrates all of us as users pretty much every day. We pour millions, sometimes billions of dollars and just countless hours into building new digital tools, but so many of them just completely miss the mark or fail altogether. So why is it so hard to get this right? Well, it's not always about bad coding or some technical glitch. The real root of the problem is often much, much deeper and a lot more human.
So, do you notice a pattern here? None of these are really technical problems, are they? Look at this list. A failure to prioritize what's actually important. Solution-driven answers. That's just a fancy way of saying someone has their favorite solution and they're going to force it in, instead of actually understanding the problem first. Ignoring stakeholders, failing to grasp just how complex things are, and this is a huge one, neglecting the real human impact of the changes you're making. See, these are all failures of understanding, not failures of technology.
Okay, so if the problem is a lack of understanding, then this solution has to be building a rock-solid foundation of understanding before you even think about building. In the software world, we call this foundation the requirements. Just think of it like building a house. You wouldn't just show up and start laying bricks and pouring concrete without a super detailed architectural blueprint, would you? Of course not. That would be insane. Software requirements are that blueprint. They are the detailed plan that makes sure what you end up building is actually what people need.
So what exactly is a requirement? Well, at its core, it's actually pretty simple. It's just a condition or a capability that someone needs. It's the formal answer to two basic questions. First, what does the customer want this thing to do? This is all about the features, the functions. And second, under what constraints should it operate? And this covers everything else, from speed and security to legal rules and, the budget. If you can get these two questions answered clearly, you are well on your way.
Now, to make our blueprint even clearer, we divide requirements into two main categories. And honestly, this is probably the most important distinction to grasp in this whole process. On one hand, you've got what the system does, and on the other, you have how well it does it. They sound kind of similar, I know, but the difference is night and day. And getting both of them right is the secret sauce to a successful project.
All right, let's break this down. Over on the left, we've got functional requirements. This is the what. They define the specific features. They usually come straight from the user, and they are absolutely mandatory. I mean, you can't have a car-sharing app that doesn't let you book a car, right? Now, on the right, you've got non-functional requirements. This is the how. They define the quality. How fast is it? How secure is it? How reliable? These usually come from the technical experts, and they define the constraints. Your car-sharing app might work, but if it's super slow and insecure, nobody's going to use it.
Okay, let's make this super concrete. Here is a perfect, classic example of a functional requirement. It's simple, it's clear, and it describes a specific action. The system must allow a user to log in with a username and password. It's a binary yes or no feature. Does it do this? Yes? Awesome. No? Then it's broken. This is the what. Okay, now let's add a layer of quality to that exact same feature. The login process should happen within 2 seconds. See the difference? We're not talking about what it does anymore. We already figured that out. Now we're talking about how well it does it. Is it fast? Is it efficient? This is a non-functional requirement. It's a quality constraint that completely changes the user's experience.
And these non-functional requirements, they cover a whole range of these critical quality aspects. We're talking about things like security. Can it be hacked? Reliability. Does it crash all the time? Performance. Is it fast enough? And scalability. What happens when we go from 100 users to 100,000 users? Ignoring these is basically like building a house with a perfect floor plan, but you use shoddy materials that are just going to crumble in a year.
So, how do you actually create this perfect blueprint? Well, it's not magic and it is definitely not guesswork. It's a structured, professional discipline called requirements engineering. It's a formal process that's designed to make sure we capture everything we need, and it usually involves 5 key steps. Let's walk through that process right now.
So here's the roadmap. We start by gathering everything in a step called elicitation. Then we sort of refine and organize it all in analysis. Once it's all clear, we write it down in specification, and then we double-check our work in validation. And this entire process is then looked after by management because, let's be real, needs and plans always change over time. It's a logical flow from just a messy collection of ideas to a really concrete plan. The first step, elicitation, is really all about listening. This is where you go out and you collect the needs, the wants, the constraints from every single person who has a stake in the project. We're talking users, business owners, the tech team, everybody. And you do this through things like interviews, brainstorming sessions, or even just by observing people as they do their jobs. The goal here is to get everything out on the table, even the ideas that conflict with each other.
So once you have that big old pile of raw needs, you get to step 2, analysis and negotiation. And this is where the hard work really kicks in. You categorize the requirements, you figure out where different people have conflicting desires, and you have to negotiate compromises. For example, maybe the customer wants a feature delivered in 2 weeks, but the tech team says it's going to take 4. You have to find some middle ground. This is also where you prioritize, figuring out what's a must-have versus what's just a nice-to-have. Okay, so after all that talking and negotiating and prioritizing, it is time to write it all down. This is the specification step, and the output of this is a formal document, which is often called the Software Requirements Specification, or SRS. Now, the crucial thing here is that this document has to be crystal clear, complete, consistent, and testable. There can be absolutely no ambiguity. Everyone, from the client to the newest developer on the team, should be able to read it and have the exact same understanding of what needs to be built.
This brings us to a massively important question. You've written your blueprint, your SRS document. It looks great on paper, but how do you know it's actually the right blueprint? How can you be sure it accurately reflects what the users really need before you spend months, maybe millions of dollars, building the wrong thing?
While the answer is step 4, validation, this is basically the quality check on the blueprint itself. You don't just assume it's right, you actively try to find the mistakes in it. You conduct formal reviews where different stakeholders all read through it. You can build prototypes, simple mock-ups or simulations of the software, and then show them to users to get their feedback. Does this look right to you? Does this workflow make sense? The whole goal here is to find and fix misunderstandings on paper, where changes are cheap instead of in code where they are incredibly expensive.
So, after you've gone through this really rigorous process, you are left with one critical artifact, the official plan. It's called the Software Requirement Specification, or SRS, and it becomes the guide, the contract, the single source of truth for the entire project team.
And the most important point here is that the SRS is a formal document that really acts as a contract. It binds a client and the development team to a shared understanding. It clearly states what the final system will do, what it won't do, and how well it's going to perform. And when disagreements or questions come up later in the project, and believe me, they always do, everyone can go back to the SRS to find the answer. It just keeps everyone aligned and moving in the exact same direction.
But listen, not all blueprints are created equal. A great SRS has these specific qualities. It's got to be correct, obviously. It must be unambiguous, meaning there's only one way to interpret it. It has to be complete, with no missing pieces. It needs to be consistent, so one requirement can't contradict another one. It must be verifiable, meaning you can actually test if the final product meets the requirement. And it needs to be traceable and modifiable, so you can track where every request came from and update the plan in an organized way when things inevitably change. So at this point, you might be thinking, man, this sounds like a lot of process and a ton of paperwork. And you know what? It can be. But taking the time to build this blueprint properly isn't about bureaucracy. It's about fundamentally increasing your chances of success. It's about setting the foundation for every single thing that follows. And here is the payoff. This is why you do it. A solid requirements document is the bedrock for all the design, all the coding, and all the testing. It massively reduces those he said, she said arguments between the client and the developers. But most importantly, it saves an incredible amount of time and money because it forces you to find problems at the very beginning when they are cheapest to fix. And all of this works together to dramatically increase the probability that your project will actually succeed. So, I'll leave you with a final thought to take with you. The next time you're using a piece of software and it just makes you want to tear your hair out, it's slow, it's confusing, it's missing an obvious feature, try not to just blame the programmers. Instead, take a step back and ask a different question. What was wrong with the blueprint? Because chances are, the frustration you're feeling today was born from a failure of understanding that happened months or even years ago.